In this video, I'm going to go over the Moving Man simulation related to how you're going to use it in the lab. When you first come onto the website, you'll see this screen. You can come up here and click on Charts. And now you have the place where you can enter the position here, velocity, acceleration. There are zoom buttons over here for the vertical axis for position, another set for velocity, another set for acceleration, and then you just have one set for time. It changes all three of them at once. You can also hide any of these individual graphs, which will come in handy later. So the first thing you're going to do is go back to experiments 1 through 3 and recreate them using the Moving Man. So for the first one, you'll enter in a value here, and that'll be the slope that you got in experiment number 1. And then you can simply hit record, and he'll move along. And if you let him keep going, he'll hit the wall, which is okay, or you can stop him before he gets to the wall. Doesn't really matter. We do need to stop it now, though. We don't need to keep recording now that he's not moving. For each of these graphs, we can change the scale. So we could change the scale of the velocity graph there, because before you could barely see. It looked like it was almost on 0 at a horizontal line, and a horizontal line on 0 is a much different motion, or no motion, than what we can see here, which is a horizontal line clearly not on 0. It's a positive value. In fact, it's 1.23, as we know from this. This line down here appears to be on 0, and it is on 0. So here what we would do now, we could try to change the scale here, but if we do that, we're going to send our line off, and we can't see the line. We always want to be able to see all of the data, and so now we can see all the data. And so now I'm going to hit the print screen button on my keyboard. I'm on a PC, a Windows PC, and then I can go over to here, go to experiment 1, and come all the way out here to the right hand side, and I'm going to paste it in here, and we're going to see it pasted in more than I wanted. And so now I can go up to Picture Tools and go to Crop, and I grab this corner and I bring it down, and then I can put that right in there, and then I can get rid of this other part too, actually. There we go. Now we can see that, put that in there. It's a little big, but it's okay. In fact, I could crop more of it out. I really don't need this part over here, but that gives you a good view of the fact that the position versus time is a straight diagonal line. At the same time, the velocity versus time is a horizontal line, and anytime the velocity versus time is horizontal, you know the acceleration is going to be 0, since acceleration is change in velocity, and the velocity is not changing at all. When it does change, like here, you see that there is acceleration. It's very brief because the acceleration was so large. He ran into that wall pretty hard. And we'll get more into that in Chapter 4. Okay, let's go back to our Moving Man simulation. We can now, we could individually change these. Type that at 0 and put his position at 0, or we could drag him around. When you drag him, it automatically starts recording, which is fine. You can just also reset all, and then everything goes back, although we do need to pause it as well. Alright, so now everything's clear, and we'll look at experiment number 4, which asks for an acceleration of 2, initial velocity of 0, initial position of 0, and then we can just simply play that. We need to go for 3 seconds. Oh, we went beyond 3 seconds. That's okay. And now what we're going to do is we're going to try to figure out where was he at 3 seconds. So I'm going to hide the velocity graph, and I'm going to hide the acceleration graph, and then we'll just look at this one graph here. And I'm also going to change the time scale. As you can see, I'm having a little trouble getting the time scale to change, but I found sometimes just show the other graphs and allows me to zoom in time-wise because I want to be able to see 3 seconds. So 3 seconds is halfway between 2.8 and 3.2. I'll get rid of these graphs again. And now, if I look here at 3 seconds, straight up here, it looks like, well, it's between 5 and 10, and it's a little closer to 5. So I'm going to do a playback, and I'm going to start playing here, and it's starting to get close to 3 seconds. Well, it's at 1.6, so go a little closer. All right, now I'm at about 2.8 seconds, and it's handy to look at this time up here in the corner. And now we can use the step button, and we can just move ahead a little bit at a time, watching the time in the upper left-hand corner, and of course it also matches on here. There we are. We're right at 3 seconds, and if we look here, we can see, again, looks like it's definitely closer to 10 than it is to 5, and we can also look at where he is, because as you do the playback, as this gray line moves across the screen, the man moves across in sync with where the time is. And so it is a virtual replay of the entire thing. And so we can see that he's at about 9 meters, maybe 9.1, something like that. And then we can do the same thing for the velocity graph. We can pull up just the velocity. And this is a little more clear because it's right on one of the axes. It's right at 6. Sometimes when you zoom in on the axis, it actually makes it harder to read if you zoom in. So you can play around with different values. Now you can see it's right at 6. That really helps when you have a grid line to help you. So right there, boom, it's right on the grid line, and so we have a nice value for that. And so you'll want to paste, well, this for experiment 4, it's already done. This is pasted in there, and this graph is also pasted in there already. And so the part that you need to do is actually all 3 of them. And I'm just using these buttons right there to hide and to show. So this is what you're going to want to paste in from the moving man into experiment number 4. All right, I hope that helped, and if you have further questions, just ask your professor.